AI working on encrypted data. Zero slowdown, 99.9% accurate. This is equivariant encryption, and it's technical. I'll explain how it actually works, not just the hype. If you want a 30-second oversimplification, this isn't it. But if you want to actually understand its breakthrough and why it matters, next 7 minutes are for you. Every AI service today can see your data, medical records, financial info, everything. This changes that. I'm Dmitry, let's break it down properly. Right now, when you use AI, ChatGPT, Claude, whatever, your data sits in plain text on someone's servers. Medical diagnosis, they see your health records. Financial planning, they see your accounts. Legal analysis, they see your documents. And with decentralized AI, where your request gets split across multiple computers, every node is a potential leak point. The industry says, trust us. But free encryption methods try to fix this. All fail for AI. Let me show you why and then why equivariant encryption works. Differential privacy adds noise to mask individuals in datasets, but it doesn't hide your data during inference. The servers still see your data. Secure multi-part computation splits data across multiple parties, secure but 100 to 1000 times slower because of constant communication overhead. Homomorphic encryption lets you compute on encrypted data. Sounds perfect, except it's 10,000 times slower and struggles with non-linear operations AI models need constantly. So the requirements were clear: actual encryption during processing, works on a single server, runs at normal AI speeds, and handles all AI operations. That's what equivariant encryption delivers. Here is the core insight. You don't need to encrypt every operation in a neural network, just the critical points where information could leak. Most calculations in AI don't reveal meaningful data on their own. It's the input tokens and output tokens where privacy matters most. Equivariant encryption transforms your data into a special encrypted domain where the AI can still operate normally, but the actual information stays locked. Think of this way. Instead of locking the safe during calculations, you give the AI scrambled numbers that only make sense with your key. Your question, what the treatment for diabetes, becomes something like a sequence of numbers. The AI processes these tokens through every layer, embeddings, attention mechanics, feed-forward networks, and returns scrambled output. Only you can decrypt the answer. Two properties make this work mathematically. First, recoverability. You can always decrypt results back to plain text perfectly, no information loss. And second, equivariance. Operations on encrypted data produce the same result as operations on plain text data. The math is equivalent. That's why it's called equivariant encryption. The encryption preserves the mathematical structure the AI needs. So then researchers tested this on a large language model. Here is what they found. 99.9 fidelity, essentially identical to encrypted inference. Less than 1% performance overhead, not 10,000 slower, not even 2 times slower. Basically, interceptable. Works with existing model architectures. No need to rebuild your AI from scratch. The breakthrough is that selective encryption applied strategically gives you both security and speed. Let me show you a concrete example with decentralized AI. Without equivariant encryption, you ask, what's the best treatment for diabetes? This goes to server 1. Server 1 sees your medical question in plain text, processes part of the model, and sends intermediate results to server 2. Server 2 sees those intermediate results, still revealing information about your query, processes more, sends to server 3. And server 3 completes the inference, sends you the answer. Every server in this chain saw information about your private medical question. Now, with equivariant encryption, you ask what's the best treatment for diabetes. Your device encrypts this as a sequence of numbers. Server 1 receives this sequence, has no idea what this means, processes it through its model shard, and produces encrypted intermediate results also as a sequence of numbers. Server 2 receives this sequence, also meaningless without the key, continues processing and outputs a different sequence of numbers, and server 3 completes the encrypted inference and returns a sequence of numbers, and your device, given the key, can decrypt it. Treatment typically involves lifestyle changes and medication. Here are the standard approaches, blah blah blah. Every server successfully processed your request. None of them knew what they were processing. Zero trust required. The model works correctly. You get accurate results. Your data never existed in plain text on any of those servers. This is blind AI inference. The servers are genuinely blind to your data while still serving you accurately. Now let me talk about limitations, because there are some. First, it's not mathematically unbreakable. Security depends on the complexity of the token transformation. With 120,000 token vocabularies, the search space is enormous, but theoretically, an attacker with enough encrypted query response pairs could attempt pattern matching attacks. The paper analyzed these attack vectors and shows they are computationally infeasible at scale, but it's not impossible. Second, key management matters. If someone gets your encryption key, they can decrypt your queries and responses. This is true for all encryption, but just worth staying. And third, it's new research. This paper is from early 2025, it hasn't been deployed at massive scale yet, and real-world edge cases might emerge. And fourth, currently supports most AI operations, but the framework is designed to be extended as needed. None of these invalidate the breakthrough. They are just the honest reality of where the technology is today. So why does it matter? This enables AI application that couldn't exist before. Medical AI that genuinely can't see your health records. Financial AI that can't access your accounts. Legal AI that preserves attorney-client privilege. Personal AI assistants that can't leak your conversations. And it might be the key to making decentralized AI actually private, where computation spreads across untrusted nodes but your data stays secure. Right now, every AI interaction is a trust decision. This research shows a path where trust isn't required. The math handles it. So, equivariant encryption, encrypted AI inference with near zero overhead and 99.999% accuracy. Research paper link below if you want the technical details. If this kind of AI research breakdown is useful, just subscribe, new video every week. I am Dmitry, thanks for watching.